Is up, everyone? Harder! Welcome back to our channel where we're here to make math easy. Pop goes the Snapple can. What's on the docket for today, Mr. B?
It's something I know lots about.
Oh yeah?
Yep. Some even say I know so much about the topic I should have my PDH in the topic. I'm pretty much a doctor.
I feel like I'm having deja vu.
On the surface, I may not seem like the sharpest tool buried under the shed, but let me tell you.
I think I know what's coming.
What do you mean?
Nothing. What are we going over today?
How am I supposed to know?
Let me guess. You didn't say anything about being a doctor and knowing everything about this topic?
I never said that.
Yep. So this video is the second part in a two-part series on surface area. So today we're going to be working on triangle prism surface area. If you didn't already watch part 1 on rectangle and cube prisms surface area, go ahead and watch that first. The link is in the description.
Could I be a doctor anyway?
We're going to teach you how to find surface area of triangular prisms, which sounds a lot more difficult than it is. We're going to teach you one trick, all right? One that you'll have to keep in mind when you're doing this that will make this process easier, streamlined, and quicker, so you can spend less time on your homework and getting outside. All right, so without further ado, let's get started. All right, so now this is part 2 of a two-part series where the last video we went over rectangular prisms and cubes, and today we're going to be going over triangular prisms. All right, and a lot of the same stuff from rectangular prisms and cubes are going to apply today. And let me kind of show you what I mean. So right here, what you may notice if you already watched my video from the rectangular prism, I made my own triangular prism. And you'll notice it's actually pretty similar to my rectangular prism, but the difference is the ends right here are both triangles. And then we also don't have that extra one here, that extra face, which created like a T, right? We don't have that one. And that's because this is a triangular prism, where if we fold up the sides and fold these in, it creates a prism. Now most people actually look at triangular prisms and they call these prisms. I don't know why. These are the ones that people typically associate with prisms, not so much with rectangular ones, but usually you'll see these and people will be using those to refract light, right? To create like a rainbow type light where you can see the whole spectrum of light. So this one is obviously paper, it's not going to do that, okay? But we are going to do triangular prisms today. So to do these, like I said, is very similar to rectangular prisms. The only difference is right here we still have rectangles, but the ends are triangles. And to find the area of a triangle, we need to do the formula 1/2 times the base of the triangle, the bottom, and then multiply that by the height of the triangle. And what needs to be done is that base has to be perpendicular to the height, which creates kind of a line like that, right? Or an L of some sort. This is basically an upside down T, okay? So keep that in mind as we're doing this. So right here, we have a problem, all right? In this problem, we have something that kind of looks like this triangular prism, right? Kind of sits kind of like that, okay? Now, just like the rectangular prisms, we're going to look at all the faces. The faces are all the sides. So this face is a triangle, okay? And we notice in the problem, it says that the bottom is 7 inches. The height, which is perpendicular from the base, goes up and that's 5 inches. And then we also notice that this side of the triangle is 6. Now what gets confusing for some people is that 6, all right, in the triangle, that can be confusing because people think they need it for the area of the triangle, right? And some people will choose that as the height of the triangle. But keep in mind that the height has to be going from the bottom, our base, straight up in a straight line to the top point. All right? I always like to think of it as if this is sitting on the ground right here, like my finger is the ground. Sitting on the ground, where's the highest point? It's right here, right? So that means we need to draw a straight line from the bottom to that highest point, okay? This is not a straight line, right? It's kind of bent over and diagonal, okay? So, just like before, we are going to find the areas of each face and then add those all up. So, that front face is a triangle. Right? And the tip I shared in the last video was look to see what's the same. So what's the same as this face? What's the same size? Well, it's not this one, which is a rectangle. It's not the bottom, which is a rectangle. It's not this side that's a rectangle. It's the back, which is also a triangle. So our front and back. And I'm only saying that because I'm holding it like this. All right, it's kind of standing like that in the picture on the problem. So our front and back are the same. Now we have to look to see what the measurements are for the other ones to see if anything else is the same. So let's do the right side. Now the right side is right here. Now I know from the picture it says this is 13 and then this is 6. So we have 13 times 6. All right, now let's look at the left side. All right, now these aren't opposite, right? They're not parallel to one another. They actually meet. These two sides meet right here at the top. So they're not opposite sides. So we can't just automatically assume that they're going to be the same measurement. All right. However, one thing that is important is that the opposite sides of a rectangle are the same. So because this is 13, this is 13. And that's a shared side for this left rectangle. So this is 13 and this is 13. And then this line right here that goes on the side of the triangle is also 6. So we have 13 times 6 again. Okay, so this right side, this left side are both the same measurement. So again, it saves us some time. Now finally, the bottom. The bottom, we actually notice, I know this is 13 because just like the picture shows, this is 13 and that shares a side with this. So this is 13 and then this one, which is the bottom of the triangle, is 7. So this one is different. And we don't have a top because it's a triangle. It's only going to have 3 sides in the prism. All right, so we only have a bottom. And usually I write it as B-O-T, okay? We don't have a bot. So that bottom is 13 times 7, okay? Now I didn't write down our formula for front and back, but our front is 1/2 times our base, which in the problem shows us is 7, and then times by our height, which is perpendicular, and that's 5. And that's going to be the same thing for the back, okay? All right, so I'm writing this way. I don't know why that is, but I am. Let's kind of correct that a little bit. Let's inch these ones in a little bit so I have some space to write our things right here. All right, that's better. So now we have some space to write these, all right? So when we're doing these, one thing that's very important is that we can do it a couple different ways. We can take 1/2 of one of these numbers and then multiply by the other one, or we can multiply these two numbers together and take half of that. Now what you may notice is 7 and 5 are both odd numbers, so we are going to get an odd number for this. And probably because we'll be breaking into 2 equal groups, we're not going to get just a whole number. It's going to have some sort of fraction or decimal with it, okay? So if you haven't watched decimals, right, decimals are very important. You need to make sure you watch a video on decimals before you do this. Okay, so 1/2 times 7 times 5. I'm going to do 7 times 5, and that equals 35. And then I have to multiply 1/2 times 35. Well, 1/2 times 35 is 35 over 2. okay? If you didn't do fractions, multiplying of fractions, I'll link the video below so that you can go and watch that. But because we're multiplying half times a whole number, that whole number, 35, goes over 1. And then we multiply the numerators and multiply the denominators. So we get 35 over 2. And that's the same thing for the back, 35 over 2. Okay, so now as we make our way down to 13 times 6 and then 13 times 7, and again, they're really kind of inched over. I'm not really happy with that. Let's move them back even more. All right, a lot better. All right, so 13 times 6. Now you probably don't know that fact off the top of your head. So what we need to do is we need to just do it on the side. That's perfectly fine. All right, so 6 times 3 is 18, carry the 1. 6 times 1 is 6, plus 1 is 7. All right, so both of these are equal to 78. This is the same problem. And then we have 13 times 7. Now I could just write it all together, or I could just add another 13, because we have 7 groups of 13 instead of 6 groups of 13. So if I just add 13 to this, it's the same thing as saying 13 times 7. 8 plus 3 is 11. There's a 1. 1 plus 7 is 8, plus 1 is 9. So our answer here is 91. Now, if you didn't really believe me or that kind of confused you, let's just do 13 times 7. 7 times 3 is 21. There are the 2. 7 times 1 is 7, plus 2 is 9. All right, so it's the same number there. All right. So now we have all of our areas here. We now need to add those all up, okay? But obviously you're thinking, Mr. Hunt, 35 over 2, why? Gross, I don't want to do that. So what we can do is we can either take this and multiply it by 2, because we have 2 of them, or we can add these 2 fractions together. Personally, I think multiplying fractions is much easier, all right? So let's make a little bit of room, let's get rid of this. All right. So 35 over 2 times 2 of them, right? We have 2 of them. And then all whole numbers are over 1. So now we have 35 over 2 times 2 over 1. If you remember from my multiplying fractions video, you may know, or multiplying mixed numbers rather, you may know that we can cross simplify. Now, we don't have to do both sides, we can do just one. We can only do it when it's multiplying, okay? So when we do that, we can look to see the denominator of one and the numerator of the other, what number goes into both. That's 2. So if we divide both of those by 2, we can simplify it. So our numerator of that one was 35, our denominator of that one was 1, and we're multiplying. So now I'm gonna rewrite our fractions. This one's gonna go here, this one's gonna go here. So 2 divided by 2 is 1. 2 divided by 2 is 1. So now you may notice that this is a lot easier. 35 times 1 is 35. 1 times 1 is 1. So 35 over 1 is the same thing as saying 35. So I'm going to erase these 2 real quick. And yes, I'm doing it with my finger because I can also do that. And I'm just going to write 35 because I already multiplied 35 over 2 twice. Okay, so this is actually my answer for both of these combined. And now we need to add them all up. All right, so let's add up the ones placed first. So we have 5, 8, 8, and 1. Nothing that can make an easy 10 and make this a little bit simpler. So instead what I'm going to do is I'm just going to go ahead and add them. All right, so 5 plus 8. Well, 5 is really a 2 and a 3, so 2 plus 8 is 10, plus 3 is 13. 13 plus 8. Well, I know 3 plus 8 is 11. So 13 plus 8 is 21. And then add 1 more, and that's 22. All right, so carry the 2 up here. So now let's add our tens place. 2 plus 3 is 5. 5 plus 7 is 12. Lost my place a bit. 12 plus 7 is 19. Then 19 plus 9, well, keep in mind 9 is really 1 and 8. So since I had 19, 19 plus 1 is 10. So that's 20, and then plus another 8 is 28. All right, so I have what appears to be my answer. So my answer is 282, and the unit is inches. And because we're doing surface area, area is two-dimensional. The shapes are flat because we're only focused on each face, and that's a flat shape. When all these flat shapes are put together, right, edge to edge, that makes it so that this shape is now three-dimensional because it's made up of more than one shape. Typically, in this one, you'll see it's made up of 1, 2, 3, 4, 5 shapes. Okay, so it is still, each shape is two-dimensional because we're doing area. So we have an answer of 282 inches squared. Okay, so again, just like rectangles, pretty much the same process. The difference is we have 1/2 times the base times the height for the triangle faces. Okay, but that's really what's different. All right, let's try one more, practice this a little bit, and then go to the challenge problem. Wait a second, what are you doing there? Let's do that again. Hey. All right. Haha, I win. All right, so let's do another problem. All right, so this next problem, just like the previous one we just did, the process is the same. Look at the faces, look at the numbers, decide what is the same. All right, so we have our problem right there. And just like before, we have one that looks different than this prism I have here. It's much taller and not as thick as this one, right? This one looks a lot bigger. So, but we can still use this to kind of see what we have to do here. All right, so that front face, all right, get out of here. That front face, that triangle, all right. And here's a tip I would also suggest. Draw the picture of what you're doing. So I'm using F for front. All right, so to find the area of that, we have 1/2 times the base. The base is the bottom, and that's 8. And then the height is a perpendicular line. It goes straight up like a rocket. All right, usually you'll find a dotted line, kind of like when a rocket goes up, it leaves the puffs of smoke. So look for that dotted line because that will show you a perpendicular line. Right, and that's 10, all right? Now, what's the same as this? Well, the back. The back triangle is the same, so it's going to be the same. They're opposites, right? They will be the same. So then we have the right side, and that's a rectangle. That rectangle has a length of 11, and then it has a height of 14. Now what's going to be the same as that? Well, there's nothing opposite of that, nothing parallel. Okay, so we just have to kind of look to see what we got. Now the left-hand side. All right, the left-hand side also has a length of 12, or I'm sorry, a length of 11. So another thing we're noticing is that the height of that is also 14. So that means that these two are also the same. That kind of works out. That's nice. All right. And then we have our bottom, which is a rectangle. And our bottom, our rectangle, has the measurements of 8 and 11. All right. So these are our areas. This is how we get them. And then we're going to write them here, and then we're going to add them up for a total. Okay. So just like I mentioned in the last one, you can take 1/2 of 8 or 10. I usually always suggest the larger number. Or you can do 8 times 10 and then take half of that. Because the operation here are all multiplying. Add a little extra dot there. We can really decide what order we want to do it. We'll still get the same answer because it's all multiplying. I like to do half of a number and then multiply by the other number. So let's just do half of 8. Half of 8 is 4. 2 groups of 4 is 8. So this equals 4. And now we have to multiply it by 10 because that's what we still have to do. 4 times 10 is 40. Now the front and the back are the same. So I'm just going to write our number 40. Down here we have 11 times 14. Now I don't know about you, but I don't know that off the top of my head. So I'm going to go ahead and write that up here and do the math. 4 times 1 is 4. 4 times 1 is 4. Is there an echo in here? All right, put our placeholder 0. Then we move to the tens place. 1 times 1 is 1. 1 times 1 is 1. There really is an echo, isn't there? All right, now we're going to add our ones place. 4 plus 0 is 4. 4 plus 1 is 5. 1 plus nothing is 1. So our answer here is 154. And what's the same as this? Well, this one right here, 154. And then what we have here at the bottom is 8 times 11. Now I know my 11s times tables. If you don't, definitely, you'll notice there's a lot of easy tricks with the 11s. 8 times 1 is 8. 8 times 1 is 8. So whatever the number you're multiplying by 11, as long as it's a single digit number, it's just going to replace the ones with itself. So 8 times 11 is 88. All right, now I'm going to add them up. Now I know I'm towards the bottom, so I kind of scoosh this one up a little bit, but we're going to add them up. So our ones place, 0 plus 0 is 0, plus 4 is 4, plus 4 is 8, plus another 8 is 16. So carry the 1. All right, now in this column, I see a 5 and a 5. That makes 10, okay? So we have 10 plus 8 is 18, plus 4 is 22, plus another 4 is 26, plus a 1, which is 27. So carry our 200s. 200s plus 100 is 300, plus another one is 400. So we have an answer of 476, but we're not done. What are we missing? Say it out loud so you look really weird if you have headphones on and you're watching this video. What are we missing? Yes, we are missing the goat. No, just kidding. We're missing the unit. Yes, I heard one of you say that. The unit. And what is the unit in the problem? Unit is what describes these numbers, and we're talking length. So our unit is centimeters, right? And because it is area, it's the surface area of a 3D object. So its area is two-dimensional. We need to square it. So our final answer is 476 centimeters squared. All right, so with triangle prisms, all you really need to keep in mind, know the formula for area of triangles. All you're doing is finding the area of multiple shapes. Always look, what is the same? These two shapes are the same. Don't do the math twice. You did it once, save yourself some time. Same thing here. If the faces are the same measurements, go ahead, write the same number, right? Don't make any assumptions, do what I did. Write it down. Well, it's 1/2, the base is 8, and the height is 10. Then look at the back. Well, the base is 8, and the height is 10, so it's the same, right? So double check. Don't assume that every single time it will be the same, because sometimes it won't. Yes, crazy. Them teachers, though. All right, so that's it for today. So, good job.
So I has a question for y'all.
Yeah, of course.
You told me you were going to talk about them pair of mids.
Yeah, but what about them? We focused on prisms.
Did you make them pair of mids in Gugu Gaza in Egypt?
No, and those aren't made of paper.
I know you said you made them prisms, but I thought you also said you made them pair of mids.
Not the same thing. Yeah, nope.
But it now has, would it be the same? Well, whip it.
What he said. All right, everyone, that is it for today. So make sure you like and subscribe, and also look at the challenge question and put your answer in the comment section below. Anyone that puts in an answer to one of our challenge questions will be entered into a sweepstakes to win a custom Mr. B t-shirt. All right, it won't smell, it'll be brand new, and you'll be the second person with one. So go ahead, add those in there. All right, watch every single one of the videos, like them, and the video to come out for the sweepstakes will be coming out soon. All right, so get a head start on that. And that's pretty much all today. We'll catch you next time.